Alright, let's work on the next problem of today, and this is going to be LeetCode number 36, Valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each column must contain the digits 1 through 9 without repetition. Each column must contain the digits 1 through 9 without repetition. Each of the 9 3x3 sub-boxes of the grid must contain the digits 1 through 9 without repetition. A Sudoku board could be valid, but is not necessarily solvable, and only the filled cells need to be validated according to the mentioned rules. Okay. Only the filled cells need to be validated. So see, same example 1, except the 5 in the top right corner being modified to 8. Since there are 2, okay. So in this case, I was going to say that this is backtracking, because a Sudoku solver is like sort of like the classic backtracking problem. But in this case, we actually don't care about the unfilled cells, right? We only really care that the filled cells are following the rules that were given. So only need to check the filled cells and make sure that the configuration is valid. So in this case, we need to check if the row contains the same number. Check if the column contains the same number. Check if the 3x3 grid contains the same number. So in this case, we could probably have an array of so array size 9 of row sets, array size 9 of column sets. And the idea is that for each row, check if the column has, or if the row already has an existing number. If yes, return false, same as row, but for columns. The tricky part is the 3x3. Well, we could check each 3x3 manually. So we can say like it would be a nested loop, and then we check the 3 there, and then we create a set, create a grid set, and maybe that works. Let's see. So going through that, it would be O of n times m, because we had to check each cell. Then here we would be O of n times m as well, because we had to check each cell within the 3x3. So this would be 2 times O of n by m. Because the main problem is that we can check which set, or depending on the row and the column, right? We can say, okay, so we only want the first 3 rows and the first, like for example, row 0, 1, and 2, and then column 0, 1, and 2. Oh, we could do that. So we could check within the sets, I think. That would still require an O of n by m, potentially. But yeah, maybe we could do that. But in the first place, we need to fill out the sets, right? So we can say val row set array is equal to an array of set, a mutable set of integers of size 9, where we initialize them as mutable set of int with nothing inside. We can say call set array is array mutable set int 9 mutable set of int. Then we can say board dot for each indexed. So this is a row and a row list. And then we can say row list dot for each indexed column value. We can say that we want to add the value within the row and we want to add the value within the set. So if value is not equal to a period, which indicates a blank value, an empty value, then we want to say row set array at row list dot add, well, if row set array at our row number contains this value, and we'll say val as int is equal to integer parse int value, return false. If the column set array at this column contains this val as int, return false. Otherwise, row set array at row, we can add this val as int, and call set array at call, add call as, or val as int. And so this starts by filling up the array, or fill up the array sets, or set arrays. And then we can do a print row set array just to see what it looks like. Call set array, and then we can return true just so that it returns something, right? We can do toString. We can do row set array for each set print line set, or looks like that's a reserved word, so row set we'll call them, Let me capitalize it. And then call set array for each. Yeah, because the arrays won't print out nicely, but the sets from Kotlin should print out nicely, right? So 537 for the row, then 6195, 986, 863, 4831, 726, 628, 4195, and 879. Then we have 56847, and so on and so forth, right? Then we can do some cheeky shenanigans. We can say for, let's say, what do we call this? Row grid in 0 to 2. And then for call grid in 0 to 2. What we will do is that we will say val let's see. We want to create a union. No, do we want to create a union of this set? No. I'm just thinking of how to do this. So we want to get this, the first 3 rows and the first 3 columns. Let me think. We want to get the first 3 rows and the first 3 columns. That gets us let's just do a print line first. We can say row set array at row grid. Call set array call grid. So row set call set. We don't need this. 0, 1, 2, 2, 3, 4. So we want to do for row in 0 to, or yeah, 0 to 2. We want to print line. We want the row times row offset, I think. So row grid times row offset. So 0 times 0 is 0. 0 times 1. Oh. Row grid plus row offset, sorry. So 0 plus 1, 0 plus 2. Then one plus 0. row grid times 3, right? So 3 times 1 plus 0 is 0, 1, 2, 3, or 0, 1, 2, 3, right? So for call offset in 0 to 2, we really want to drag this in. This will be call grid times 3 plus our call offset. So we have our first row set. Which is 537, 6195, and 986, which is correct. Then you have these 3. Then you have the next 3, and then the final 3. This is trickier than I thought. Like, it's not the row and the column part that's tricky. It's the 3 by 3 grid. And I want to do this in a way that makes the most sense. So, let me think about this. So we can get the row pretty easily. What does our column consist of? Or what does our 3 by 3 set consist of? It consists of these 3 sets. The 3 sets in the row, the 3 sets in the column. Okay, so what do we do with that? We have a row, we have a column. How can we use this information to build up a set that only contains what we have in here? What happens if we intersect the first row and the first column? Well, we just get the first number. Oh, and any numbers that happen to be in there. But not necessarily ones that we care about, right? Those aren't necessarily numbers that we care about. So we don't want to intersect them. We don't necessarily want to union them either, do we? We don't want to union them because the row and that column don't really matter as a union. We kind of really only want the numbers that are within this 3 by 3. But how do we do so? Let me think about this a little bit more later on. And let's just do for now the naive approach. So we'll do a board for each indexed. Indexed call value. So this will go through each cell. Let's see. So we want to take the three most. I think we could probably still make this work. We just want to do instead we want to do the board. So what we want is maybe to do this. This is gonna get messy. So for each row, we want to get the row offset. And then for each column within the row, we want to get the column offset. So this will go, we want the row grid times 3 plus row offset. And this should work. 5.3 dot 7 dot, oh, Not quite, not quite. Let me think about this some more. How could I do this in the most naive way? Call grid 0, row grid 0. For row offset in 0, row grid, or 2 for call offset in 0, 2. Row grid is less than 3 and call grid is less than 3. Then we do row grid less than call grid. Call grid plus plus. Else row grid plus plus. Let's see. So this would be row 0, 0, 0, 1, 0, 2. And call grid 0. If row grid, actually that's fine. If row grid less than 3, if column grid is less than 3. Let's see. We just want to print line cell is at board at row grid times 3 plus row offset, call grid times 3 plus call offset. So if the column is less than 3, then we add it. But if we go to 2, so let's say that we're at 2, or we're at 0, then we increase to 1. 1 is still less than 2, then we go to 2. Then it's not less than 2, then we check if row grid is less than 3. If row grid is less than 3, then we increase row. We can just do call grid plus plus if call grid is equal to 2 or is equal to 3, then row grid plus plus and call grid is equal to 0, and this row grid will eventually hit 3 when we get to 2, 2, and this will break out because this is an AND. So we should be fine there. So 53.6.98. Then we can say print line new by 3 by 3. So not particularly fast, but we'll see. Okay, so now we want to create a set within here. Within the row offset? No. Within the entire thing. So val grid set is equal to mutable set of int. If this is a mutable set of int, and we can say val value is equal to integer.parseInt. Oh, if board at row, okay, cell. We'll start with just the cell part. Right. And we can say if cell is not equal to period, you can say value is equal to integer parse int at our cell. Then we can say if grid set dot contains value, return false, grid set dot add value. And this resets every 3 by 3. So we shouldn't need U anymore. But I suspect that this might be too slow. This seems like a way too straightforward answer. But who knows? 100 by 100 makes sense for an n by m answer, but we're doing 2 times n by m. I feel like there should be a way to do this using the row and set arrays, but I've gone over the time. So if this times out, then I'm gonna take a look at how people are handling the set arrays. Like, there's gotta be a way to do it. I just can't think of how. Or maybe they don't. I don't know. Who knows? Let's go ahead and run a submit. Yeah, it still seems slow, but it's not actually that slow. Surprisingly, not that slow. So I'll definitely take a look, but I think this is fine. It could probably speed it up in some other ways. But in any case, I think I'm going to leave it here for now. And I hope you learned something. So I'm really not sure what the lesson here is. Just iterating through the array, using a set, and checking, like, I guess this seems more like a design problem rather than an algorithms problem, but maybe there's something to do with set and like set intersections and unions and sort of inclusion-exclusion principle. There might be something there. Like if a value is contained within the... I don't know. I do not have enough brain power for this right now, but in any case, I hope you learned something, and I'll see you for the next problem.